Good afternoon, everyone, and welcome to this webinar, which will explore practical approaches to digitalizing renewables operations for scaling. My name is Megan Farber, and I am the Head of Research at Green Power Global. And it's a pleasure to welcome so many listeners today. We're really looking forward to this session. Please be aware that we are recording this webinar, and within the next day or so, we will send through the recording and also the slides for you to review. I'd like to thank our webinar sponsor, Prediktor, a leading industrial IT solutions provider, for partnering with us on this webinar series and sharing their expertise on today's topic. So I will now move on to welcoming today's speakers. To start with, we will hear from Thomas Pettersson, who is currently Prediktor's Vice President for Operations Management. Thomas has been with Prediktor since 2004, and prior to this, he worked at ABB and has a master's degree in engineering cybernetics. We will then hear from Prediktor's Chief Executive Officer, Espen Krogh. Prior to stepping up as CEO in 2012, Espen headed Prediktor's software development activities and was the main creator of the OPC of the courses on OPC and OPC UA since 1998. He's also a member of the OPC Foundation Markets Advisory Council. And then finally, we'll hear from Tabizo Jaji, who is a PV engineer at utility scale solar PV company Solar Capital. Here he oversees the South African operations and maintenance portfolio of large-scale power plants, solar power plants, and has a wealth of experience with O&M analytics across 4 continents. So throughout the presentation, you can submit your questions via the Q&A box at the bottom of your screen, and we will get through them at the end. Please indicate who this question is for specifically, and I'll try and get through as many as possible. So with that, thank you very much, and I'll hand over to Thomas.
Thank you, Megan, and welcome everybody to this webinar. So as Megan said, the topic for today's session is how to digitalize operations and specifically how to accomplish this in a scalable manner. And the topic came about after having several discussions with clients in the industry, wanted to have some more advice related to how to tackle their digitalization journey. So if we can give some answers to those questions throughout this workshop, I would be very happy. So the topic of that we will address in this webinar today are these 3. First of all, I'll give an introduction to the rationale why renewable digitalization is important. Then Espen will talk a little bit more about strategic considerations when implementing a scalable and sustainable asset management platform, and go a little bit deeper into how integrations between systems should be handled. Then lastly, Tabizo will talk more about the experiences with implementing both SCADA and portfolio asset management systems practically, and also how to operate them. And this is sort of a continuation of the last webinars that we've been running. First we did last year was more related to general aspects of how to utilize asset management systems and SCADA system as well to maximize operational performance. Then we had a second webinar where we focused more on the analytics part and how to utilize data coming from renewable assets. Both for continuous improvement and how to automate processes. And all these webinars are also available from our web pages at prediktor.com. So I'm really happy that there are so many of you that are coming from the industry here today, because digitalization is, we believe, a very extremely important topic to address to make renewables even more competitive. And at Prediktor, we have addressing these challenges related to industrial digitalization for now more than 26 years. And I would say that all of us working at Prediktor has a really strong drive towards utilizing technology in a way that can make it possible for our clients to become best in class in terms of operational excellency. And our technology platform is now in operation globally in several thousand production critical installations. And the experience that we've gained through these 26 years has sort of been leveraged in our product, which we call PowerView. which is both a SCADA system and a technical asset management platform for the renewable industry. And we say that these systems are both asset-centric and information-based. And by asset-centric, we mean that the assets are in the center and that all the data that is being collected from it and put into reports, into analysis, services, and so on, comes directly from the assets. And by information-based, we mean that the information and the knowledge that is being provided by the system is in line with the targeted stakeholders' needs. So if you want to have a full understanding of what the PR rates are, what your major losses are, doing production reporting towards the asset owners and so on, that is being done directly and pushed from data coming from the system and from the assets. So looking at some of the challenges that the industry faces and some of the mega trends, what do we see? I've listed up a few challenges and trends that I believe is important in terms of how to approach digitalization of renewable assets. First of all, as you all experience, there is a declining cost of balance of system that everybody in the industry is experiencing. And it's obvious to me that this is an area where asset management system plays a huge role. And by this, I mean how you should get sufficient insight into the performance of both your assets and your portfolio versus costs throughout the asset's lifetime. We also see that the portfolios and the assets are getting larger. That means that they're producing more and more data, and these data need to be handled or managed in a sensible manner. This also relates to system integration that Espen will talk about. So there's obviously a potential for economics of scale if you manage this in a proper way. This is also related to the complexity of the portfolios. That not only goes to the size of the assets and the portfolios, but also the complexity in terms of integrating with battery system, with other type of renewable systems like wind and hydropower. This complexity needs to be handled by a proper data management system. Also, we see that there are more and more stakeholders that sort of reflects the complexity of the organization that has specific needs and requirements in terms of accessing data from these systems. That could be analysts, it could be asset owners, asset management, O&M, utility and suppliers, and so forth. This needs to be addressed as well. And all of these stakeholders also demand a certain type of transparency. And by this, I mean that it should be full openness into the data streams that the assets are producing to actually fully understand how you should put actions in place in order to optimize your performance. So these are some of the challenges, and this needs to be considered when you look into the targets and the objectives that you would like to do in terms of digitalization, which you could say is threefold. You want to obviously maximize the lifetime performance of your assets. You want to reduce the cost of the operation, and you want to not necessarily reduce the business risks, but you want to optimize the business risks in a way that these three elements are balanced. And minimizing the operational cost does not necessarily imply that you are able to maximize the lifetime performance. And also reducing the risk too much might go on compromise with automation of the different processes that you would like to do. So that's basically my introduction. All these aspects also relates quite a lot to the way you are integrating different field devices and systems surrounding a renewable asset portfolio. And this is some of the topics that Espen will address in his presentation now. So then I leave the word to you, Espen.
Thank you, Thomas. Well, I'm going to look into the situation when you find that your enterprise has already several assets in your portfolio set up, and the potential challenges you face with bringing new technology in. So scenario is your enterprise has a lot of sites with renewable plants and equipment set up. And these equipment and sites have equipment from many different vendors out there. So the challenge is when you bring in new technologies, and new technologies, we're quite certain that new technologies will arise in this field for quite a few decades. There's new hot topics every year now, and there's a lot to be done in order to manage those assets as good as possible. So on the enterprise level, there's a strong direction towards standardizing all of those types of new technologies across the portfolio in order to have an efficient operation and the potential for having a centralized team addressing all the potential challenges you see out there in your asset portfolio. But the challenge I've already mentioned comes around when you look at the data streams, because a lot of those technologies you like to put out there, they would rely on being fed by data streams from your equipment in order to do that task of doing optimization or whatever you would like them to do. But the data streams, they all kind of have different colors. And by colors, I mean they typically have different protocols. They have different data contexts and structures around the data and how they are described within the protocol, based on which supplier actually has set this up and provides the data to the centralized system. You could, of course, try to standardize on the supplier across your portfolio, but most will find that that is hard to do on a global scale. At least when you're different regions, you will have different suppliers performing or being able to deliver to you to different extent in different regions. And also it's the potential challenge you will see that if you're in a lock-in with a specific supplier, you have less freedom or choice when you continue to build out your portfolio. So the challenge then is looking at different colors of data streams, different protocols, and potentially different ways of sending in the same type of data from the same equipment type, but from different suppliers. Then you end up with a situation that every time you bring in a new technology, you need to integrate that new technology into all your different assets. And that's potentially a manual job if they all look different. So let's say you have through the next decades, you will have N new technologies onboarding into your portfolio. And then you have something like M assets. You have N times M manual integrations to cope with. And every time you bring in a new technology, you need to go over and do this. So this is what we call integration hell. And it's nothing new for renewable assets. It's something we've seen in many industrial fields years ago. And Prediktor has been studying this quite closely and developed together with big energy suppliers a strategy to actually cope with this. Of course, an immediate thought of actually remedying situation would be to standardize on the local SCADA supplier. The local SCADA supplier will then be able to standardize on his side the protocols and the data structure that he embeds within his local SCADA. But again, this brings you into an unlocking situation with a local SCADA supplier, and it might be the same situation here that in different regions you would really like to have maybe another supplier. And so it's not a perfect solution this either, and especially when you see the potential of consolidation among companies and bringing new asset portfolios into a bigger enterprise after an acquisition. You end up with different local SCADA suppliers anyway. So it's not, I would say, a sustained solution this either. But what have we learned in Prediktor? How can we actually solve this challenge and look at this in a holistic way of solving this one time and for all? Well, if you look at the asset and structures out there, it's quite evident that they all have more or less the same set of equipment. So there's a limited set of equipment types out there. And those equipment types, they can be described in a specific way, and you can describe them and which different types of entities you have, but also you can describe how they are all interconnected. And so the equipment types, the relations between the equipment types, this can more or less be standardized in a standardized information model that goes for all your assets. And this structure, this type of describing your asset, will then be able to be put out there to all the different assets in your portfolio. So what this suggestion is that before you bring the data into your centralized systems, you should map them to this standardized information model and bring that information model through a standardized protocol into your enterprise systems and strategy. And is this possible today? Are there such technologies available? Well, actually, there is. And with this, it comes to benefit that when you see this, you have only like one specific integration when you bring new technology in, and then when you scale it out throughout the portfolio, it's more or less a plug and play experience. So this is the way to go. And the technology we're talking about is, I would claim this is OPC UA. So OPC UA is the only real-time protocol that can host any type of information model. So when you select this, a standardized protocol, then that can host a standardized information model, you actually solve the case. So OPC UA is more or less the standardized interoperability standard that had been chosen for a wide range of different industrial segments. So this is a technology that actually has various communication stacks set up, client server, pub sub, etc. And it embodies what I've already told, an information model standard. So you can describe any type of structure in any way you would like, but preferably within a standard. And best of all, it's a fundamental security concept underneath. You don't have to be that concerned on cyber threats if you deploy this and scale this across your enterprise portfolio. And of course, it's good to know it's been chosen by Industry 4.0 Consortium, the German standardization activity that tries to figure out the future for the German industry. So OPC Foundation, that is the organization behind OPC UA, is now collaborating with a lot of different other standardization bodies to bring their specific information model structures into this protocol. So that's what's happening now. So this is a large-scale standardization activity organized by OPC Foundation, but with a lot of details going on in the various other standardization bodies. And almost all suppliers within automation and a lot of equipment manufacturers as well will support this standard. And we also see that all the bigger industrial enterprises, they are now embracing this standard. So in Prediktor, we have this technology stack set up for energy asset portfolio optimization. So the first thing we have is a reliable data capture system. It's very important to secure high quality data capture and bring the data further into the applications. As we all know, shit in is shit out. So everything you build on a weak data capture structure will have damaging consequences up in the applications. And then we have this element that I've just talked about. When you have the data, it's very important to understand the context of the data if you're going to use them in any type of things like analysis or whatever. But I would claim it's not enough to only have the context. You should assure that the context is described the same way across your portfolio and preferably across the whole industrial segment. And that's where we see that OPC UA comes into play to give the standardized contextualization of data and still able to cope with very large volumes and a diversity of structures underneath. And then on the top, there's a lot of standard functionalities in current asset portfolio management systems. I will claim that we have an interesting setup when you like to automate and do and leave some of the jobs for optimization to your algorithms. Then we have a significant interest in technologies for you. On these elements, I will claim we're a bit different than several others. We have field-proven technologies on reliable data capture, not only deployed and used by us, but used by other companies like Wärtsilä, Schlumberger, and Kongsberg in their own applications. That's our technology. Then we made an early choice to go with OPC UA for doing the contextualization of the data. And this pays off now when this has recently been chosen by the industry standardization organizations in many, many segments. And then, of course, we have the specialized competence in algorithms. Okay, so let me just summarize this, that portfolio asset management within renewables is definitely a dynamic field, and a lot will happen in the future. So it will be a challenge if you're ignorant to this element of integration health, because then you will have a hard time bringing these new technologies into your asset portfolio. My claim is that standardized protocol and standardized information model to contextualize the data is an holistic approach to cope with this challenge. And we know that this works because we've been doing this with other industries, and like the oil and gas operators that have even larger, I would say, data stream volumes, and also many more applications on the enterprise side. And if you look across the industrial segment, OPC UA is winning and in the field of standardized asset data. And Prediktor is happy to say that we can now offer an enterprise standardization asset technology that you can bring out to your complete portfolio, and we will assist you in getting this in place. And by selecting us, you will not be in lock-in, because we will always provide this standardized structure to the enterprise, between the enterprise and the assets. So you're free to choose whatever you like on either side if you'd like to bring other suppliers as well. Okay, that was my part. And now I'm going to try to hand over the session to you, Thabiso.
All right. No, thank you so much, Espen. Before I get into the details of the presentation, I would like to blow a horn to Grid Power Global, Prediktor for the opportunity, and I'd also like to extend the appreciation to all the listeners. In my mother tongue, Kiridumelang, which means greetings to all. Getting into my presentation with respect, I would like to believe that my industry colleagues have said mouthful details about how to digitalize operations for scaling. And as a result, I will speak of the experiences and how, as a comparison to other solutions, Prediktor has come to the rescue. Therefore, I would like to draw your attention to our everyday life, because I believe that if you can relate something to your everyday life, no matter how complex it is, you tend to have a better understanding of how it works and why it should be a benefit to you. So in that case, I'll move to my first slide. So having a portfolio management via SCADA solution is no different from having your assets, such as your pen, your book, your income, that is managed by an FSP X or financial service provider X. All it comes to is the issue of speed and asking the right questions and having the right tools. So in South African context, we need to understand, especially when looking into renewable energies, your PV systems, we need to understand what actually drives the business. So the bottom line is that what drives your business is actually the tools and the speed that you have. And then there's this famous saying that says, if you have a wrong tool, no matter how much effort you put into something, the results will always be poor. So in a way, you should look at Prediktor or PView as a tool that will assist you to achieve whatever goal that you put in place. So without any delay, I would like us to focus on this chart here or graph, where actually I'm showing a general human's portfolio curve. So once we understand or we relate to this curve, the next slide will be able to relate more about the IPPs and the teams that are involved and the things or the solution that we require in order to make sure that these systems performed as they should. So at the beginning of our lives, all of us, we had our guardians, our parents, or whoever was there before you, who invested money in buying clothes or preparing for you to come to this planet. But as you grow on, or as you grow older, you tend to incur some spending, or you spend more money. You go to college, you spend more money, you get a job, you buy a house. At some point in your life, you'll have to reach a point where your expenses are over the limit. But as you grow older along your life, your expenses will go down, down, down up until the end of life. But it's different from person to person, but this is just a general way of life, of how life it is. But at the same time, when you are born, for some people who are lucky, they do have trust funds. So in a way, you have money that is generated to and will be directed to you. So as you grow older, you'll have money that actually is generated and it goes into your livelihood on this planet. And at some point, you'll earn a big salary if you are within a company and so forth. But as you grow older, you change jobs, you change position and everything. And some of your skills are not necessary because there's young blood. Your salary competitive will also go down, and then that's it. But every day, we ask ourselves, how can we make sure that our earnings curve is always above our spending curve? In a way, we need tools. So the moment you start asking yourself these questions, it is when you are actually thinking about a winning strategy. So that's where you should ask yourself, why do you need to have a portfolio? The main reason is to have a winning strategy. And I've already said that a winning strategy is actually speed and the type of tool that you are having. So in the business of life, you have all these organizations. Some they will sell you whatever and say, we can do this and make sure that when you are 30, you earn this much. But before you go into that, you have some few questions that you ask yourself. Questions like, how do I connect what I'm saying to what I want to happen in future? And this is where you have to ask yourself, how do I connect theory with practice? What do I need to have? What are my limitations on this planet? What is the complexity of my problem and how I can approach it? And then the bottom line, you ask yourself, what comfort will myself and the people at large have? This is the everyday life that you are fighting, trying to have portfolios and so forth. It is the same approach when it comes to IPPs or solar power plants or renewable energies. So in the next slide, you'll understand that these are the similar challenges that you are facing, but there is a tool that you need to employ in order to make sure that you maximize your profit, the livelihood, or the life cycle of a power plant and so forth. So moving into a second slide. In this slide, or this curve, it actually shows you a general IPP portfolio curve and how SCADA functionality can assist you as the end user to meet your goals or your demands. As I mentioned about life, I want you to try and relate whatever that is going on here with my previous slide. At the beginning of any IPP project, there's an investment that goes into the project. But during that project, as time goes on, you'll have variable expenditure where you spend money. So the cost of the plant will also increase as time goes on or as period goes forth. But you know for sure that at some point, I do have some fixed spending that I have for this portfolio or for this IPP. But at times you'll have this variable spending. This may be like incident where something big or there's a damage or for something that you've never thought will happen. These are some of the variables that you will incur or you'll experience along the way. But the first goal for every project is to reach what we call the break even, where you actually reach a point where what you have generated or what you have made as money, it's actually equal to what you have invested in your project. And then post that break even, that's where we, in our mother tongue, we say, ubuna shimo, meaning you are harvesting your investment. So when you look at this, you can tell that, okay, investment was put in, the spending went on and so forth. And then secondly, earnings started from COD, you managed to accumulate your bill revenues every month and then, but now the goal is to make sure that the gap between or the scale or the space between your earnings and your spending is very short. To achieve that, you need speed. In this case, speed, you'll have to achieve it through SCADA. Why am I saying SCADA? Because the reason we employ SCADA is because we need automation. And automation, we're trying to take advantage of speed. So now, if you employ a SCADA that has poor functionality, the consequences that you are going to have are going to be very bad. If we were to compare you with plant X somewhere, for you to reach this point, break even, it will take you more than you have predicted. Because if you have any downtime or you have any technical downtime and so forth, your SCADA doesn't have the proper functionality or KPIs to pick up this incident and give you information so that your O&M team can respond in time. So hence where we talk about the issue of O&M response, and your SCADA functionality will determine how fast you reach your break even. As soon as you reach your break even, it's not the end of the world. You still need to have a very capable SCADA and a very responsive O&M team to meet your demands. So if your SCADA, again, it's bad, for a lack of a better way, for you to actually harvest what you wanted, you won't be able to enjoy some of your investment. So that is why you need to ask yourself a lot of questions. And then moving on, you'll understand, okay, no, I have this life cost, how much it will cost me and so forth. So moving into the next slide, that's where I'll be talking about some of the most important questions that you need to ask yourself before you can employ any SCADA system. Moving into choosing a SCADA system, any business, you can ask yourself a lot of questions that you have. But these are some of the very basic questions that you should ask, and some of the questions that some of my colleagues in the industry, when we are working on a day-to-day, will ask yourself, but were these questions asked? Why is it performing like this? If they asked 1, 2, 3, 4, 5, we wouldn't be having this problem. So this will assist you to have a better understanding as to what questions should I ask before going to this. Number one is, what kind of data do I need to monitor? The type of data that you need to monitor, it is informed by the type of critical equipment that you have or you are using on site. So for instance, if you have a 132 kV HV transformer and you have an auxiliary transformer that is 110 kV, you may weigh your options. Okay, I know that monitoring these two equipment will be expensive, but which one should I prioritize? This is the type of question that will assist you which one or which data you should collect from your field devices. And another question you should also ask yourself is, what kind of equipment am I using to capture data? If you go into the market, everyone will tell you a lot of stories. I can do this device will be able to monitor this and that. But you can always do your research and make sure that you use the right equipment that has a longevity or durability for the lifespan of your power plant, so that you know you harvest more than enough for your investment. And another question that you should ask yourself is, what kind of HMI do I need to view my data? This is your human-machine interface. And this will also inform you in some part or some way, what type of inverters should I go for before going to business? And then another question that you should ask yourself is, from where do you need to access your data? This is very critical because in any business, you have a hierarchy or different people or with different positions. Some that are different with different interests into data that you are collecting. You can't use the same data that you collect from the field that you give to your technical people to send it to your CEO. You'll be wasting their time and their effort. So you need to scale your data. So you need to ask yourself, what type of machine am I going to use locally? And what type of a machine or type of reports am I going to send to the management or technical team and so forth? These are type of the questions that you need to ask before going to SCADA. And then the most important one is we can say whatever that we like to say about SCADA system, the question, but again, you must have the will. How many or how much time and manpower are you willing to invest in or employing into providing a SCADA solution? This is where you think about your timelines and you make your forecast and so forth. And the most critical one, it is commercial direction. This is where I think a lot of people having experience like in the industry, I see that they mess a lot. If I tell you today, if you can have 2 plants or 10 plants today, all of them using different SCADA system, in 10 years time, at least 50% of the power station, their SCADA solution or system will be outdated. So when you employ a SCADA, you must think about at what rate does technology evolve, and the SCADA that you are going to employ, does it go with time? These are some of the questions that you need to ask. And then the most important one also is the issue of service and support. You see, when you are doing quotations, sending quotations, or you need to measure or scale the time of response that the service provider is giving you. When you are at the time where you are issuing or you are requesting quotations, this is the time where you want to give business to the service provider. But if you see that their response is very lacking, what makes you think that as soon as you have employed their SCADA solution, their time response will be better than before? You need to think about, because at that time you would have given them money. So now is the issue of saying, okay, we have this issue. And then you check how often do they respond. So these are some of the things that you need to measure. And most importantly, it's how much the system will cost. And then from this, I'll therefore give some of the case studies and some of the challenges that we meet as operators or control monitoring officers or some of the field technicians that actually makes the job harder because the system that was employed is not good enough, if I may put it in that sense. And this is where, yes, thank you. And this is where I'll talk about some of the challenges or the experiences or difficulties that we encounter on a daily basis when we work in the industry. So this is where I commend Prediktor solution in comparison to other SCADA solution. And I'm speaking specifically about renewable energies. I'm not talking about other disciplines or sectors. There was this one point in Plant X, where the O&M team, they went and changed the set points of the inverters in such a way that when the inverter power reaches a certain point, the inverter generates more reactive power, so that it does not exceed the set point of the power or the active power that will cause the inverter to trip. So when they did this in Plant X, they didn't tell us. They just kept it to themselves. So because we're using a SCADA system like Prediktor, we're able to pick up this situation very fast. What happened for us to be able to pick up this issue is that with Prediktor, if you have an overview of Prediktor or the plant that is performing, you'll be able to tell there is this KPI, we call it index energy performance. It measures your energy, the relationship between the energy that you produce and the insolation. So obviously the ratio will be averagely around 100%. So even though your inverter was showing that no, it's performing, that value of IPI went to left. Then we asked ourselves as colleagues what was going on. And then we went and used another feature called Process Explorer. And this is where you dig deep into the performance of any inverter. And then we realized that, no, man, the O&M team on Planet X, they actually did these settings to avoid these inverters to trip. But they didn't want to tell us because it was not a good thing by that time. So we're able to pick up some of these issues through Prediktor. So you can imagine how you can pick up some of these issues if you are using a SCADA system that has limited issues. And another thing, one of the best SCADA features that I like about Prediktor is that even now, and this is directed to you as the audience, especially who are in the industry. If I can ask you this question, last week, how much was your non-controllable losses? And how much was your controllable losses? You won't be able to give me that answer. As long as you didn't employ Prediktor, and I'm very sure. So with Prediktor, what it does, it actually cuts all your losses and put it in categories. So you don't need even an external auditor to come and tell you that your losses are as a result of 1, 2, 3, 4, 5. On a daily basis, in any given period, you'll have these losses and you'll know that, okay, the controllable losses were 5%, 50%, given the circumstances. And then that's the point where you will hold O&M team accountable. And these are some of the things that we need to look into in order to make sure that you optimize your plant performance. So, and then we can say as much as we want about Prediktor and some of the cases that we encountered and some of the problems that we solve, and we believe that other SCADA solutions won't be able to provide. Some of the issues that are very important is making sure that when you want to employ SCADA, in this case, I would say any SCADA, make sure that you choose the right technology. And I think even ESPN emphasized on this case, because if you are going to use bad instruments on site, it won't assist the SCADA because SCADA relies on the instruments that are on the field to collect the data. So make sure that your type of technology that you're using is very good, because it will affect how your SCADA functions. And then another issue is the issue of connectivity, making sure that your connection or your network of your plant is stable and so forth. These are some of the issues that, but again, even if you have bad connection with Prediktor, this is Planet B, somewhere in Europe. It had the same problem, but Prediktor has this feature where you can actually manually correct the data through the system. So you'll go and download the data from the actual substation, then you'll go to Prediktor and then you'll log that data. And then everything will just calculate automatically and then it will run automatically. And then as I've mentioned, the issue of poor functionality, anyone can sell SCADA to you, but make sure that you check the functionality, because functionality is automation, automation is speed. And then commercial direction, I've also talked about it. And then this is the most important thing. People will think that this is a complex issue to employ SCADA because we are saying a lot of things and all that. But I must give it to the team at Prediktor and with their people that they're working with. They have a very, very, very great team that they work with. So if you feel like you don't have a proper team who can do analysis for your plant and so forth, Prediktor is designed in such a way that I always make this argument that even a grade 6 learner or student, you can train that student for a week. Trust me, next week they will be able to tell you what's going on and be able to monitor your plant. So I'll move on to the next slide. Thank you. And then some of the values that I've gained through Prediktor, like I've mentioned, it was giving you full control. And some of this control is that if you have any issues with data replication, you actually have control to rectify that data manually, making sure that everything is fine. And then some of the advantage, obviously, is time and speed. If it takes someone 1 hour to do something that Prediktor can do in 1 minute, already the one who can do something in 1 minute has an advantage over the other one. So another thing is the issue of 100% human error, eliminate that. In South Africa, we have all types of reports, your NASA reports, your DOE reports. These are reports that compliance reports. You need to make sure that the data that is there is correct and so forth. So if you do these reports manually, it takes time. So imagine, for instance, in practical, we used to analyze over 30 power plants in 1 hour. I'm talking about over 30 power plants in just 1 hour. You'll be able to go through the Prediktor platform and check the critical key points. Then I'll be able to tell you that, okay, this one has this issue, this one has this issue, this one has this issue. And then from there, you move on. And then the OM team mobilize, they go into site. This is how you this is how you win in the industry. So you need speed. And then obviously the issue of mitigation of risk, it also goes hand in hand with that. And then the consistent update of your health or your critical health, to always update you about the health of your transformers, the inverters, and then you'll be able to plan your O&M around that. And then it also reduces the downtime, because you are able to pick problems fast, and the O&M, they are able to respond very quickly and solve solutions. And then the most important one is the 100% user feature. If you are using Prediktor, you can just tell the guys and say, you know what, I'm thinking that I need to receive this type of report monthly or weekly. In the report, I need to see 1, 2, 3, 4, 5, and it should look like 1, 2, 3, 4, 5. Within a week, you'll be able to receive that report that you wanted them to design for you. And it will be a standard, and it will be exactly the way you want it. So this is what I mean about 100% user customer features, meaning that you can send a report that is dedicated to the CEO, a type of report that is dedicated to the lenders or whoever is involved in the project. Then moving into my last slide, my last slide. And then there's this question that, why should you partner with Prediktor? So in closing, I would like to say, if Newton didn't ask the right questions, we wouldn't understand the laws of motion the way we understand it today. If Albert Einstein didn't ask the right questions, we wouldn't understand relativity. If Galileo didn't ask the right questions, we wouldn't have a better understanding of gravity, vacuums, and the universe. So it is very key to ask the right questions so that you employ the right tools and you work at a decent speed to meet your goals. So with Prediktor, as you can see from the pictures there are so many things that is going on there, but we're able to pick up any issues within 10 minutes, no matter how complex or critical it is. Thank you. Moving on to you, Thomas.
Thank you for that, Tobiso. Good points. One final slide that I just want to conclude with before we open for the Q&A session, and that is related to the partnership between supplier and client, which we believe is extremely important in order to succeed in the matters that we've talked about in this webinar. We really believe that long-term partnerships between client and suppliers is essential in order to achieve these high-hanging targets. And by this kind of partnership, we very much would like to, in our processes, to invite the client in on product development, and we really want to have a high degree of transparency between the strategy and the direction that our companies have in terms of optimizing their operation. So I leave it with that. Thank you, Tobiso, Espen, for the presentations. Then I think we should open up for Q&A session, Megan.
Okay, great. Thank you so much, Thomas, Espen, and Tobiso, for all of your presentations. They were really interesting. I'm not going to delay. I'll go straight into Q&A. To start with, actually, be good to just kind of summarize. So, Espen, from what I've understood from your presentation, data contextualization is the essential element to making use of data at either the enterprise or portfolio level. Would you say that's correct?
Yeah, I think you grasped one of the key essences, Megan, but I also believe, because this is such a hot topic, talking about contextualization of data, and that's one critical element around that many seem to miss, and that is that you also need to ensure that the contextualized data is the same context when you try to describe the same thing on another place, as a portfolio. Hence, you need to standardize also the context by itself. in order to actually tap into the benefits of doing this. So that's what I mean about a standardized information model, is to provide a standardized context to your data.
Okay, great, thank you. So what are some of the top risks of digitalization projects, and how should they be mitigated? This is open to anyone.
Thomas?
Maybe I should start answering that. And first of all, I think it's important not to consider it a project, but rather a process. It's sort of working continuously with digitalization and setting some goals on what you would like to achieve based upon the structure and the strategy of your company. I mean, do you want to be really hands-on in terms of optimizing your processes, providing O&M and technical asset management services, or do you want to outsource that to a third party? If you really have ambitions on gaining this profits, as Tabisa were talking about, then you really need to be hands-on in this process. And I mean, it's as simple as answering or asking yourself some questions about what do you know. Do you know about your losses, for instance, as Tabisa discussed as well? Can you mention the top 3 losses from your portfolio for the last period of time, or do you not know that? If you don't know that, then you obviously need to address those in this kind of setting up the targets and in the process itself.
Okay, great, thank you. Tabisa, this is a question for you. In South Africa, which companies can we use to help us with implementation of your SCADA, both hardware and software?
Thank you. Obviously, for software, it will be Prediktor, and then for hardware, it's what the company is called Left Click. But I know some of the guys who've been in the industry. Like, I don't know if it's okay to mention those companies or a company that can employ a Prediktor SCADA system. But I know 1 or 2 that can do that. But I'm not sure if I'm allowed to mention their name in this platform.
And in the upper layer of app services, what kind of integrations does Prediktor have with other software or digital services?
In terms of field integration, as long as you have open machine-to-machine interfaces, we can basically connect to all type of equipment that is sitting locally. When it comes to integration with third-party, sort of, if you're talking about commercial asset management systems, for instance, we also believe that it's really open to have these open APIs that can expose the data sets that we provide through our information model that Espen was talking about to do proper communication. And we believe that, there needs to be a synergy between these kind of expert systems in order to achieve the best in class on the different areas that you're operating.
Okay, great, thank you. Another question, what happens if our supplier does not support OPC standards?
Well, I can answer to that. I believe this is most likely a situation that can occur many times when you select equipment suppliers on the specific plants, etc. And then I would advise that when you have the idea, you will transmit the same data into the enterprise for general users across the portfolio. Then you're sure that there's a translation from the more proprietary or other protocols to an OPC UA standard, and also with a proper mapping to a standardized information model. So many providers can do this kind of translation, and also Prediktor does have a module that could do this for you. Take any type of standard, remap it, and serve it to the enterprise with OPC UA. Even though you haven't chosen us either on the local SCADA or on the enterprise system, we still have this feature that we could deliver to you.
Just one comment on that note, Espen. One concrete advice that we usually give when you're in the process of procuring field equipment is to make sure that to address integration aspects when you put out the general technical specifications. Make sure that you have addressed how and what type of information that should be provided by the equipment that you procure. it's a lot easier to put that in really early in the phase rather than coming late in and asking for certain data sets or certain interfaces.
Okay, sure, that makes sense. And how should one start off a digitalization project? What are kind of the first things to consider?
I'm not sure if you would comment on that from your experience, Tabiso. You're muted.
Again, can you repeat the question, please?
Yes, of course. How should you start off a digitalization project or process? What were the first things to consider?
As you well understand that data is very critical, Megan, and then it actually informs us as what we need to do in the future. So you need to make sure that you employ the right people with the right tools in order to make sure that you collect the right data that you can use for your future project and all that, in understanding that data is expensive. Thank you.
Yeah, I could just add to that. So I totally agree with you, Tabisa. But besides the data, I think when you think about key concerns is whether you can actually evolve your portfolio management strategy in the future. Yet you have the freedom to evolve. And that's why I emphasized on you should try to avoid a lock-in situation with suppliers, etc., because that brings you to a potential dead end. And that's where standards come in. And with standards, it's twofold. It's both specific protocols that transmit the data, but it's also the standards or the structures that surrounds the data. And that's where I'm talking about the information models. So I think that's one of the key messages I have. In order to ensure you have a future-proof strategy for coping with your portfolio management, assure that you actually get these standardization elements in place.
Okay, great, thank you. Another attendee has asked, in one of your previous webinars, you talked about how AI can boost PV performance. How does this tie into the wider digitalization process at scale?
Yeah, maybe I could address that. Obviously, this is one of the parts that relates to all three aspects that I was addressing related to maximizing the performance, reducing the cost, and managing the risk. We talked about this in the previous webinar as well, and that in order to be able to implement AI, you need to have good quality data. And if you don't have the proper data quality in place, then you can forget about doing either any type of automation or analysis. Secondly, we believe that also it's important for at least the clients that have great aspirations in terms of implementing and exploring AI methodology themselves to have the proper APIs to be able to extract data. We know that a huge amount of time is spent just getting a hold of data from assets in order to implement AI or machine learning algorithms. So if you have the right interfaces, that makes it possible for easy extraction of data from assets throughout the whole portfolio, generate the ML or AI algorithms, and then deploy them back into the portfolio again. That is something that we address through this information model that Espen was talking about. So structuring of data, contextualization, and data quality.
Okay.
And there again, Thomas, I totally agree. And there again comes into play the element of using a standardized structure. Because, of course, AI is all about training networks on data. But if the data structure is different from one site to another one, you actually you don't have the ability to deploy a prediction algorithm that was trained on one asset to another asset. So you need to ensure the data is described the same way.
And I don't think this is just an academic approach to it. I mean, this is real challenges and real experiences that we have by implementing our own AI algorithms using the same concept by just both to implement the algorithms and to deploy them back into the portfolio again.
Okay, great, thank you. A kind of follow-up question to that. In the field of data collecting, do Prediktor just use data in the field or also satellite data for comparison?
We use both type of data. We have basically collected data that comes from the assets, either being material stations or basically all the electrical data that is being collected from the sites. But then we augment that data set with data from third-party suppliers like material stations or satellite imaging and so forth. So it's not a single source of data to provide data into this kind of system. It's a matter of using the appropriate data sources that is available for the task at hand.
Okay. I think you also mentioned earlier about the kind of very fast evolving pace of new technologies and asset management in general. How do you envisage renewables asset management to evolve in the next decade?
I think automation is a key aspect here. We talked about this in previous webinars as well, and by the increasing complexity and increasing data volumes that is being collected, there's no way that you can have an efficient O&M and asset management organization that can cope with this. So you need to automate it. You need to have the system telling you the top 5-10 losses that you're facing, and then it needs to be a proper decision support system that guides you to the right direction on what you need to do in terms of activities. I would say that is my top pet on that.
Espen, Teresa?
And just to add, sorry, Megan, just to add, like when you choose whatever SCADA that you choose, I think it is also important that people, they need to choose SCADA, not necessarily a DCS. So what I'm saying, you need to choose something that is database. Because if you have data, if you have 1, 2, 3, you can do whatever that you want with it. But if you have something that will just give you a solid figure and leave it there, it's going to be difficult to make use of it in the next 5 or 10 years and so forth. So you need to choose something that is database, because with data, you can do whatever that you want.
Yeah, I think a lot of interesting things going to happen in this field as we go forward, Megan. You will see automated drone systems that does all the inspection and feeds the algorithm that does a decision by itself, etc. So all this, it's not hard to believe this is going to happen. We see this is emerging right now, and so the best thing you can do in order to prepare for that is to ensure you have a proper set of strategies that makes it possible for you to take all of this into your enterprise, and that's really the main theme of my presentation.
Okay, great, thank you. We've got time for just maybe 1 or 2 more. Can Prediktor be utilised in other assets such as mining plants or heavy mining equipment, or is it mainly just for power generation plants?
The question was if this system is applicable for other industries rather than renewables. Was that the question?
Correct.
Yeah, so PowerView is sort of the application that we have been developing and targeted towards renewable energy specifically. The platform that we have based that on, though, is something that we've been developing the last 26 years for Prediktor, and that has been applied in several other industry segments like manufacturing and other other energy sources as well. So I guess yeah.
And would it apply to energy efficiency?
Yes. We have applications that does energy optimization on other areas other than renewables as well.
There was a question here. I can see the same direction whether we have for hydro plants, and I guess that's a yes. We have several hydro clients in Norway.
Great. Okay, I think I'll just wrap up with one final question then. Just to kind of summarize, what would you say is different or special with Prediktor's approach to assisting digitalization of renewables asset portfolios?
Well, I think our answer to that is that we do have more or less the functionality you expect from an O&M system on the enterprise side. But we also have some very interesting analysis and AI functionalities that are more rare. But the essence, I believe, where I see would differentiate a bit is about this element preparing for the future, going through standards in both protocols and information models. I don't see a lot of other suppliers actually going about telling about this, because of course most of the suppliers would like to facilitate and get that lock-in situation with you as a client, but we really don't believe that's sustainable. We know that we will supply you with a set of features and functions that we will be best in doing, but we also know that you will need other suppliers that will bring new technology to you, and then it needs to coexist with our system. And the best way to prepare for that is if we also can serve all the data we collected through these standards.
Okay, great. Thank you. Well, with that, I will wrap up then. Thank you so much, Thomas, Espen, and Taviso for sharing your insights to all our listeners attending today. It's been really interesting to learn about the approach to digitalization to ensure it can be scaled. So we're really looking forward to hearing more from you in our next webinar series with Prediktor. So keep out an eye for more details coming on this soon. And in the next day or so, we will send out the recording of today's session along with the slides. And we've also had some people requesting contact details for Prediktor, so we'll make sure to include those in the email so that you can get in touch if interested. And with that, I'll thank you very much.
Thank you very much, Megan.
Thank you, Megan. Thank you.
Have a good day. Bye.
Bye.